or we don't know how to use our notes, or this just looks really weird. So which is it? Is it we just don't know? It looks weird.
That looks really weird.
Looks really weird. Okay, so obviously you guys know I teach 6th grade, so I did have to teach this to myself about a week ago because it's been about 1,752 years since I've done this. So I'm always keeping it pretty simple. My whole thing is whatever makes it easiest. So when you see a -1, you simply flip this fraction. So this becomes 3/2. Then break it up looking at 1/5 squared. 1/5 squared, what does that mean we're going to do with 1/5? What does squared mean?
Times 2.
No, not times 2. Raise your hands. Raise your hands. Yes.
Times 3.
Nope. Ariana.
You would times it by itself.
Yes. So this one becomes 1/5 times 1/5 because you're doing an exponent. And then here we're just going to multiply straight across. What is 1 times 1? 1. And then 5 times 5? 25. So then if that's what we did for 1/5 squared, what are we going to do for 3/8 to the third? What are we going to do? Richard?
Multiply itself 10 times.
Perfect. What do you get when you do 3 times 3 times 3? Raise your hand. Yes. Nope. 3 times 3 times 3. 27. And then what do we get when we do 8 times 8?
64.
64. And then 64 times 8?
512.
512. So now we've kind of gotten rid of our exponents, but we're not done yet. What do you think we now need to do with 3/2, 1/25, and 27, 512ths?
Multiply.
Yes. So down here, you're going to do 3/2 times 1/25 times 27, 512ths. Now, I'm going to be really nice to you guys. I'm going to tell you this bottom number. You have to do the top number. Stand up when you have your answer. Now, don't worry about trying to simplify this or anything. Just get that top number, and then we're going to talk about it from there, okay? All right, Jeffrey, what did you get when you did 3 times 1 times 27? 81. All right, so essentially this is your answer. There's nothing that you can divide 81 by and 25,600 by. So that is your answer. Now, tomorrow on your test, you're going to see a question very similar to this. What I want you to remember most, you see a -1, you're flipping your fraction. Exponents with fractions, you're just simply multiplying them by themselves, not by 2 or 3, but by themselves. Okay? And always try to look to see if you can simplify. But like I said, you can't simplify this one, so don't worry about that. All right, go to number 2. And Ms. Collins, you can jump in anytime if I say something wrong or whatever. Okay. All right, so this one says, use a single exponent to write an expression with the same value. So again, I want you to try. If you have no idea and you don't have notes to look at, I just want you to stand up. I want you to try. When you have your answer, then you can stand up. you think about technically when it's a negative, it's already a fraction. So what do you have to do to make it not a fraction?
Oh, wait, what?
So like this is technically a negative and your exponent. This is already a fraction. Don't think about it that way as much as think about like this is division. So what do you do with your exponents when you have division? So think about it that way. It's close. Don't erase it. You need to say that. Because as soon as I do it, you're gonna be like, all right. If you're standing, you are not talking. So, negative? So, put something around that, so. Alright. Gonna go ahead and go over this one. Now, Jeffrey, I got a question for you. Saw something on your paper that was kind of interesting. So, Jeffrey, you have it like, what was it? This, and that? Is that what you had on your paper? Let me grab your paper, because I really like it, because it might make you guys think a little bit. So Jeffrey has this, and then he put keep, change, change. You guys remember hearing that at all?
Yes.
Okay, so think about division, right? Keep, change, flip. Well, this obviously is not a fraction, but what do you think it means keep, change, change? Well, what are we going to change those subtraction symbols to?
Adding.
Adding. Okay, so then this actually just becomes okay. Another way that you can think about this is the division. When you have division, do you add exponents or do you subtract exponents? You subtract them. So if we're looking at just exponents, we do 8 minus a negative 1. Well, what do we do with this negative and this negative? To get rid of it. Or not get rid of it. Like, so you essentially multiply a negative times a negative, right? Which then becomes 8 plus 1. So there's a couple different ways to solve this problem. Whichever way makes more sense, whether you're doing the keep, change, change, or you're doing just looking at negatives, multiplying this times that. Okay? But nonetheless, the correct answer is 5 to the 9. All right, go to number 3. All right, so we're finding the value of this one. So if division means subtract, what does multiplication mean? Add. So here, again, just looking at your exponents. What do we get when we do 3 plus negative 1? 2. So your answer for this one is 4 squared. Right? Okay, so remember, division, go back to your last one. So this one, division equals subtract. So put that on there somewhere. So division equals subtract, and then on this one, multiplication equals add. So just some notes to keep on your questions so you kind of have it. Okay, go to number 4. All right, number 4 says circle all the true statements. So I want you guys to figure out if what is going on here equals here. Stand up when you have your answers. think about what I just told you with the multiplying and dividing. Show your work. Show how you're proving it, if it's right or if it's true or if it's false. Show your work. Gotta show me why it's true, why it's false. And guys, if you're struggling with these, you should definitely have your notebook out, at least looking at that foldable that you have. All right, go ahead. It's okay if you're not done. Have a seat. So stand up if you said the first one is true. Nobody? Okay, so raise your hand and explain to me why it is not true. All right, Ariana?
Instead of multiplying, so you'd be adding the exponents instead of adding the exponents.
So they did not add? They actually what?
Multiply.
They actually multiplied. Okay, so remember, when it comes to exponents and you see multiplication, should be addition. All right, the next one. Stand up if you said this one is true. All right, Kira, why?
Because it's multiplication, so you're adding exponents, and negative 2 plus 5 equals 3.
Perfect. All right, so that one is true. So we'll go ahead and circle that one. All right. Stand up if you pick the next one as being true. Nobody?
I didn't understand it at all.
Okay, and that's fine. So we'll talk about it. All right, so who did not understand it? All right, Brayden, what'd you get for this one?
I got x to the negative fifth power.
How?
Or x to the fifth power.
How?
Because I did